of this fantastic run. Here is chapter 5, number 3 in real number systems. This is going to be 5.7, arithmetic and geometric series. Arithmetic and geometric series. So we're going to explore some ways to write the terms of arithmetic series or sequence, sorry, and then use the formula to find the general term of an arithmetic series. Sequence and series are different things. Write terms in a geometric sequence and use the formula for the general term of a geometric sequence. All right, let's dive in. So what the heck is a sequence? Well, a sequence is a list of numbers that are related to each other by a rule. The numbers in the sequence are called the terms. A famous example of a sequence is the Fibonacci sequence. The Fibonacci sequence occurs quite often in nature. You see it in everything from the design of petals of a flower to the swirls of a snail's shell. So the sequence goes 1, this is the first term, 1 is the second term, 2 is the third term, 3 is the fourth term, 5 is the fifth term, and 8 is the sixth term. So you may see the pattern. How are we getting each one? So you're given these two values, and then to get to the next one, you take the two previous ones and add them together. So 1 plus 1 is 2. To get to the A4, we're going to have 2 plus 1, which is 3. To get to A5, we're going to have 3 plus 2, which is 5. To get to A6, we're going to have 5 plus 3, which is 8, and so on and so forth. Okay. All right. So what is an arithmetic sequence then? Arithmetic sequence is a sequence in which each term differs from the preceding one by a constant amount. So think of like a slope with a linear equation, right? So it's a constant difference between them, or a common difference you may also see. So it's a common difference in each element. So if you look at any two elements in this sequence, okay, there's a difference of 4 between each of these. And just to kind of give you an idea of the arithmetic sequence, if you think of a number line, here's, let's say, it could even be the first sequence, right? The first step, the third, the second one, the third one, and then the fourth one. Okay. Then the first element in the sequence is 142. Then at 2, so going over 1, my next one would be over here at 146. And 3 would be up here at 154, or 50, sorry, and then at 154. And so each of these, so the difference here is 4 over 1. In other words, each time you go up and over, you're going to go over 1, and you're going to go up 4. So this is the slope of this line here, if you will. And that dictates then that you have a arithmetic sequence. Okay, so it's the common difference between each term in the sequence. Okay, so that's what an arithmetic sequence is. All right, so let's look at an example. So writing the terms of an arithmetic sequence. All right, the first 6 terms, those are in a sequence whose first term is 6 and has a common difference of 4. All right, so we start with 6. To get to the next one, the common difference would be, well, 10 take away 4 would give me 6. Okay. The next one would be 14, and 18, and 22, and 26. So it's the first 6 terms. 1, 2, 3, 4, 5, 6. And if you look at the difference between 26 and 22, that's 4. 22 and 18, that's 4. 18 and 14, that's 4. 14 and 10, that's 4. And 6 and 10, that's 4. Okay. The general term of an arithmetic sequence is starting with the first term and then moving out after every term after that. So you can write it arithmetically as the first term, A1, and then based where you are in that sequence, just like we were talking about up here, first, second, third, you're going to have 1, 4, 2, 4, 3, 4. So that common difference then, in that last example, depends on where you're at relative to the initial term. So you just multiply that number in your step times your common difference, and then that will give you that element of the sequence. Okay, and what does that look like in formula term forms? That's this relationship right here. So a to the n, the sequence or the term that you're interested in, is equal to the first term plus one less than the value of the digit times d. You may be wondering, where does this n minus 1 come from? Well, if you look back up here, this first term doesn't get counted. So here, this is going to be 2 minus 1 to get to that first. 2 minus 1 to get to that first difference, because you don't have a difference before this. So it starts here. So that's why it's n minus 1. Okay, so you don't start counting until after you've already stepped. So, so you end up with this formula. And let's see how that plays out. Okay, in this example here. Find the 8th term in the arithmetic sequence whose first term is 4 and whose common difference is -7. So plugging in what we know, we want the 8th term. Our first value is 4, and we're going to look at 8 minus 1. This is n minus 1 times a -7 difference. Simplifying, you get 4 minus 49, which is -45. So the 8th term is -45. Okay, so you can see how this formula can help you find values in the sequence when it gets really far away, and it would be hard to count out. Doing 8 wouldn't be horrible, but it would be a little bit time consuming. But if this was 18, that would be a lot longer. Okay. Geometric sequences are when you have a common ratio. The common ratio is multiplicative. The arithmetic, the common difference is the additive. So the difference between a geometric sequence and an arithmetic sequence is here you're multiplying by a common number, and the previous one you're adding by a common number. So arithmetic sequences grow linearly, and geometric series grow non-linearly. Okay. But what you can see going between each one of these terms is you're multiplying by a common number. So here I'm multiplying 4 times 2. Sorry, 4 to 8, which means I'm multiplying by 2. Going 8 to 16, I'm multiplying by 2. 16 to 32, multiplying by 2 and 2. So each time I'm moving in the sequence, I'm taking the number and doubling. Okay. You also note here to define the ratio, then you just take any two consecutive terms. So if we took 625 and divided it by 125, what we would get is the same ratio, which is 5. And sure enough, if you multiply 625, or say if you multiply 125 by 5, you get to 625 exactly. All right, writing the terms in geometric series or sequence, write the first 6 terms with a common ratio of 1/3. So here, you're going to multiply each time. Okay, so the first one is 6. Get to the next one, you're going to multiply by 1/3, so it's going to be 2. Then to get the next one, you're going to take that one, multiply by 1/3, so you're going to get 2/3. And then you're going to get 4/9. And then you're going to get okay. I think I multiplied by the wrong. Oh no, that's right. Okay. I think I was saying 1/3. Oh, I did miss it up. That's where I made a mistake right here. Sorry about that. So I multiply 2/3 by 1/3, and I'm going to get 2/9. My common ratio was 1/3, not 2/3, which is what I was thinking for a second. And then I multiply 2/9 by 1/3. I'm going to get 2 over 27. That's 1, 2, 3, 4, 5 terms. And then finally, I'm going to go 2 over 27 times 3 is that 81? Let's see, that's 2 and a 1. That's 6 and 2 more. Yeah, that's 81. So here are my first 6 terms of the common ratio, where the common ratio is 1/3. Right. The geometric term of a the general term of geometric sequence is similarly to the last one, but you're going to take your A1 and then multiply it by R to whatever power you're at, -1. So this is R to the 1 or 2 minus 1. This is the same thing as 3 minus 1. It's the same thing as 4 minus 1, and so on and so forth. And the follows from exactly the same reason as the previous one for arithmetic sequence. Using the general formula for the general term of a geometric sequence. Okay, we want to know the 8th term of a geometric sequence whose first term is -4 and whose common ratio is -2. Right, so plugging in, we want a the 8th. We have -4, -2, 8 minus 1. So this is -4 times 2 to the negative, or -7 to the -2 to the 7th. You have 2 to the 7th is 128. Multiplying that by -4, you get positive 12. All right. Writing the terms of a geometric sequence. Writing the first 5 terms of a geometric sequence, whose first term is -6, whose common ratio is 1/3. Okay. So each time you're just going to multiply through. Look, we did that example. And the 5th term of the geometric sequence is -6. The common ratio is -1/3. So again, doing this one here, it's going to be -6, and then multiplying -6 times 1/3 is going to give us a +2, and then a -2/3, and then a positive 2/9, and then a -2/7, and then a +2/81. Okay, all right. I hope that was helpful, and I will see you in the next video.